Hello and welcome back to the Electrical Building Design Show. My name is David Robison and I'm your host. Today I want to talk to you about arc flash calculations. More and more engineers are being called upon to do these calculations for their projects. Previously, this was typically done later in the design process after you've got everything specified. It was typically something that you handed off to the contractor or to your gear manufacturer, and they would do those calculations. It's starting to become an issue in a request for you to do the arc flash calculations earlier in the design, potentially during the permitting stage. When you do your arc flash calculations, you pull up your arc flash calculator and you provide it some inputs and it outputs the values. I want to talk a little bit today about what those calculations look like, because most engineers who are doing this, you've probably done some training where you've worked through what those inputs are. You've used the calculators and you've used them for doing your arc flash calculations, but there's very few people who've actually looked at the calculations themselves. One reason for that is to look at these calculations, you actually need to have this book. This is IEEE 1584, the 2018 edition. I've also got IEEE 1584, the 2002 edition. And the reason most people haven't seen these is because these are each $800 a piece. They're not the cheapest books. They're not terribly expensive in the grand scheme of things, but it's not the kind of thing that you purchase, and it's certainly not something that you do for some light reading. So unless you have a particular reason to be looking at the calculations, you've probably never held these books in your hands. You've never looked through the calculations. You're really trusting your software developers to be implementing these properly. I'm one of those software developers, so I got a chance to actually look at these documents. We purchased them, we implemented them in our software. So in terms of the history of arc flash calculations, it actually starts in 1982 when Ralph Lee published what is now known as the Lee method, named after him. These calculations are based upon a theoretical model of how the arc flash is going to happen. So it is based on theory. It was something that he put together that in 1982, with the computer power that they had and where they were in terms of the development of the industry, what made sense for them to be doing at the time. It was a beginning, and it's where we started. The industry, as arc flash danger became more and more something that the industry was aware of, the industry realized that we needed something a little bit more robust than that. And that's what the 1584 standards came from. So the 2002 edition, that's this first one, 2002, they came out with the first version of these calculations. It was based upon 300 experiments. So essentially they did 300 arc flash explosions, measured the intensity of that explosion, and then did some curve fitting on the formulas and came up with formulas for what that incident energy is going to be based upon that arc flash. That's a good start, but it was still a pretty limited set of data. It didn't cover a huge range of voltages or other things in terms of the parameters. So the industry also realized that something more needed to happen. They also realized that it was going to be expensive, that running all of these tests is not the cheapest thing to do. The history of this is not great on the internet, but I did a little bit of research to figure out what happened with the 1584 2018. What happened is the IEEE realized that they needed to do more testing. They realized it was going to be expensive and they didn't have the budget. So they actually went out to the manufacturers in the industry and they did fundraising. It looks like most of the manufacturers put up about $500,000 each. So I saw that Siemens and Eaton and Square D, they all contributed $500,000 to this effort. Looks like about $6.5 million in total was raised, or at least that was their goal. So they collected this money from the manufacturers. That allowed them to run a lot more tests. So for 1584 2018, they were able to run 2,000 tests. So significantly more. That's another order of magnitude in terms of the number of tests that they run. So they ran all of these tests, they did their measurements, they threw some curve fitting on it, and that's the calculations that we're using. So realize when you're using these calculations, it's not the precise calculations we have for a voltage drop or for a short circuit analysis. This was something that was done empirically, measured empirically, and then curve fit. So just keep that in mind when you're using these calculations, that in terms of the precision, don't get too caught up in having things correct to multiple significant digits, because the calculations and the formulas probably actually aren't that accurate. They can get us directionally in the right spot in terms of having safety, and it's important to run these calculations. Realize there's a wide margin of error on these calculations. You also need to keep in mind what the calculations are doing and what the level of protection that's being attempted is. The 1584, the 2002 talks about this a little bit in the introduction. They changed how they talk about this, but I like what they say in the 2002 a little bit here. It says that when we're used, PPE for the arc flash hazard is the last line of defense. So the idea is that if you have arc flash, you need to have the PPE on to protect you. You really don't want to ever be in a situation where an arc flash is happening. So there's lots of talk here and in other standards about preventing arc flash, because that's really what you want to do. You don't want to ever be in a situation where this happens. If it does happen, we want to have sufficient gear on to protect the worker in the field. The level of protection from 2002 is the desire to provide enough protection to prevent a second-degree burn in all cases. So it's not to prevent all burns, it's not to prevent first-degree burns, it's to prevent second-degree burns. So some degree of burns is actually acceptable under the calculations and the standards that we're using. There's some risk doing work on electrical equipment live. The arc flash protection boundary, so this is the boundary distance that's calculated. This is how far away you have to be from the arc flash, again with no protection on, to be limited to second-degree burns or to prevent second-degree burns. So you can still get a first-degree burn when you're that far away, but it's not going to progress beyond that. So that's what that boundary distance is, and that's what it's calculating. In 1584, 2018, they move it and they talk a little bit more still about the limitations of what's being calculated. One of those limitations is that this is, again, focused on burns. It's not focused on all the other issues that are going to happen if you have an arc flash, because they're loud, they're bright, metal's going flying. So they specifically say, due to the explosive nature of arc flash incidents, injuries can occur from ensuing molten metal splatters, projectiles, pressure waves, toxic arc byproducts, the bright light of the arc, and the loud noise produced. These other effects are not considered in this guide. So the arc flash calculation is really just dealing with the energy and preventing burns. The other stuff is addressed in other standards, and the industry is obviously trying to keep workers safe to avoid those dangers, but realize that there's a lot more to the arc flash, just the burn danger. So that's what's going on with your arc flash. That's where the calculations are coming from. It's some curve fitting to experiments that were run, 2,000 of them. So it was a pretty extensive set of experiments covering a wide range of voltages and configurations of bus bars, but it's still a finite set, and it's still based upon the empirical data that they were able to calculate. Continue to use your arc flash calculators. That's going to be the best way to provide safety in the field for the people out working on the projects. So we need to continue to do these calculations. Just keep in mind the limitations of what the calculations are doing and what they're protecting for.